All right. Hello, folks. My name is Andrew Owen. I'm a facilitator with the OSPool, and I'm going to be giving the training today about how to use containers on the OSPool. So I've got some slides here. There's also a bit of hands-on portion if you have an account and want to follow along. You don't have to. I'll be demonstrating it as we go. So I'm going to be sharing the slides here, putting the link to the slides in the chat. Hopefully you can access that. And then we'll go ahead and get started. All right, one presenter. And if you have questions during, feel free to raise your hand or put a message in the chat, and myself or one of my colleagues will get to helping you. There we go. Okay. I think I'm set up now. So thanks for joining. Like I said, we're going to be talking about how to use containerized software on our system. The idea here is to just demonstrate and explain how containers work and how you can use them on the OSPool to deploy your software. So I mentioned this already, but my name is Andrew Owen. I'm a facilitator with CHTC, which is, and also with the OSPool. Sorry, I forgot which context I'm in here. There's a couple of my colleagues on the call right now. There's Mats Renge out of California, my colleague Amber Lim, who is in the same place as I am. And there's a few other facilitators that are going to be answering emails during office hours when you have questions. So we're here to help you folks get access to the OSPool and learn how to use it to do your computing research. Before we get into the nitty-gritties here, if you do have a question, feel free to use the raise hands option or put a message in the chat. We will be going, this is meant to be a learning opportunity for you, not just me spouting off information here. So feel free to interrupt with any questions. So a little overview of our agenda today. We're going to be talking about why you'd want to use containers on the OSPool. We'll talk about how you can find existing containers, how you can build your own containers, specifically using Apptainer, how you can test the container that you built, and how to use the container in your OSPool jobs. So that's what we'll be going over today. First, we'll start with why you might want to use a container. As you may or may not know, the OSPool is a very distributed system. We have contributions from computing sites all across the country and beyond. And these are all, very distinct and unique sites that are contributing their resources. And within those sites, there can be multiple different kinds of machines and operating systems that they're contributing. And so overall, what that means for you as the user is that you don't know the software environment your job is going to be running in. And that can be a bit tricky because, if you don't know which version of Python 3 is there, then it's going to be hard to write your script to use to run your Python 3 program. So the point of a container is to address this issue, to deal with this disparate computing environments you can run into. And by using a container, you're able to provide for your job a consistent environment with the same set of software, same set of libraries every time it runs. It gives you the opportunity to create your environment to make it as complete as you need it. So, some sites may have Python 3, but they might not have NumPy or SciPy or one of the other packages or libraries that you need for your job to function. So a container is a way of making sure you have everything you need in order for your job to execute in terms of the software. And what's another really great aspect of the container process is that it's a reproducible environment, or at least it is fairly reproducible. So the way that you create the container, or that you can create the container, is something that you can hopefully replicate later down the line just by copying a file. You put all the instructions in a single file, and then you can use that to create the container. So that means if you ever need to remake it, or if you want to share it, you just have to share that instruction file. And it's easy to reproduce or make small changes if you want. So we're going to use an analogy here, and we're going to go with everyone's favorite thing, which is food. So running software on your own computer is kind of like cooking in your own kitchen, right? You have put everything in there. You know where everything is at. You know that there's maybe, you've got a mixer and you've got a cast iron pan, and you've got a sink in a certain spot, and you've got cardamom and ginger and whatever other spices and ingredients you have. So that's great when you're cooking in your own kitchen. But what makes things like the OSPool a bit hard? Oh, apparently there's a slide for that. So you already know what you have, and you mostly know where everything is. You may forget, but you should be able to find it. And you have full control over what you have in your kitchen, right? So when you're running this program on your computer, if you need another library, you install another library, you're good to go. So the problem is that running on a shared system, or running on someone else's computer, like you do on the OSPool, is like cooking in someone else's kitchen. And especially on the OSPool, this is like cooking in a complete stranger's kitchen, in a different state, in a different country, in a different culture, right? So a lot of the things that you may expect to be quote unquote standard, in this kitchen is not going to be true, when you go to the stranger's kitchen instead. So on someone else's computer, what's already there? Well, is R installed? Maybe. Well, probably not. Most places I've seen don't have R installed by default. Quite a few will have Python, but maybe it's Python 3.6 and you need Python 3.12. And as I mentioned earlier, that doesn't even begin to consider what are all the packages that they have installed. Okay, well, let's say that they do have Python, but there's something else you need, or maybe they have Python in a location you weren't expecting. Do you know where anything is, right? You know that you need a Fortran compiler. Maybe they have the Fortran compiler, but maybe it's not in the path by default, or maybe you need to manually link the libraries. And these are things that can be kind of difficult to do, especially on the OSPool, where these resources come and go, and your job rarely runs on the exact same machine, 2 times in a row. And finally, you are not allowed to change whatever you want. I mean, there's a certain level of things that you can change, right? So, you know, the countertop in this kitchen, where you might be putting ingredients in a bowl and things like that, mixing stuff around. That part you can change. But I assume this stranger's kitchen that you're working in, the stranger is going to be very unhappy if you decide to replace their stove or their oven or their refrigerator. And they're not going to want you to mess with that sort of thing, or they're not going to want you to remove ingredients and change things up. So, um, when you're running on the OSPool, you're running essentially as a guest user. And it's not the technical way of describing it, but it's how I like to think about it. Um, you can do very limited things just where the job is running, and you can't affect anything about the software environment, which becomes a problem if they don't have the program that you need in order to run your calculation. So the solution here, and this is again an analogy to containers. You'll want to think like a backpacker. So, and when you go backpacking or you go hiking, you're going to go take a trip to the Himalayas or something. Uh, you know, you can only use the stuff that you bring with you. There's not going to be a grocery store at the top of Mount Everest for you to get what you need. So if you want to make a meal, you're going to have to bring those ingredients with you. And if you need tools to do that, you need to bring the tools with you. So this is sort of the same idea here. When you're running a job on the OSPool, you're going to need to take your software with you. And ideally, it's going to be able to run wherever you go. And this is what containers can help us with. They help make the software portable. Portability here is just this idea of being able to essentially run the software anywhere. Now, containers are not the only way of doing this. If you are pretty good at programming, you can figure out how to do this. But for those that aren't, containers are a powerful and I'd say relatively easy way of making sure you have a portable software environment. And to extend on this a little bit more, you can think about a container as kind of like bringing a whole kitchen with you. So if you imagine like an RV or a food truck or something like that, you want to cook some food for a party at a friend's house. If you bring one of these containers with you, you don't have to worry about, where their salt is or if they have, a slicer of some sort. You can have all the tools and ingredients you need in that mobile kitchen, in that food truck, and be able to make your recipe, make your meals however you like without having to worry about what kitchen did they have and what ingredients do they have and things like that. All right, so that's the analogy here, just to put a little bit finer point on it. Um, the couple of big reasons why we want to use containers on the OSPool. One is a container gives you a consistent environment. As long as you don't change the image, every time you use the container, it's going to have the same software, same libraries, whatever else you include in it. This is very great for making your custom software environments. You want to install a particular program, you want to install particular R packages or Python packages, things like that. You get control over how the container is constructed initially. And so that means when you go to use it in your job, it's what you wanted it to be. And this goes nicely with handling special environments such as GPUs. If you're interested in using the GPUs on our system, there's quite a few places where you could get a container that's going to be functional with most of the GPUs that we have on our system. That doesn't mean that your software is necessarily compatible with the GPUs, but at least the container itself will be able to interact. And if your software is compatible, then it'll be a piece of cake. Another thing that containers do nicely is sandboxing. So in this context, what we mean by this is it's very good at isolating the job from the rest of the system. Now, HG Condor and the OSPool already does a pretty good job of this just by default, but a container makes it even easier or even better at this isolation. So it means that nothing else can peek in, nothing else you won't be able to see any other jobs data. And this is true normally, but it's harder to hack around those security measures we put in place if it's running as a container. Okay. So that's why we want to use containers. There's a couple of ways we can use containers. So in the general industry, there's two standards right now for the technologies for using containers. There's Docker, and then there is Apptainer, which was formerly called Singularity. It's a bit of a mess, but it was Singularity originally. There was a fork where Apptainer is the open source version now. In most places, well, it seems to be a mix of which ones people are using. Docker is sort of the commercial standard, but they are a commercial enterprise, which comes with all of those, potential issues. Apptainer is open source, so it's a lot more available for institutions. Okay. So today we're going to be talking about Apptainer for the most part. You are able to switch to convert a Docker container into an Apptainer container, and you'll actually see this, or the process that we'll describe will do that sort of automatically. So next we'll start with finding existing container. So when we want to build or use a container, we can save ourselves a lot of time and trouble by just using ones that already exist. So there's quite a few places where containers already exist. On the OSPool, we actually provide a list, a set of containers to make it easier for our users and colleagues to work on distributed systems. So this first link, you can find this on our documentation website, but it's just our list of containers that we have available. Otherwise, you can also find a common place for containers is Docker Hub. That's generally free to pull from, at least they have rate limits, it's complicated. But for most folks, they don't notice it. Um, there's also a few other things, but in general, what you can do is just with your favorite search engine, provide the name of the software you want to use and container, and you're probably going to end up with a pretty good listing. Now, just like with any software that you find on the internet, you'll want to, do your due diligence, make sure it's not it's not a security risk or it's an untrusted or unverified source. But there's quite a few different large official websites that provide containers. Just, do your due diligence, make sure it's a valid source. And if you're ever not sure, feel free to ask us and we'll be happy to provide our guidance. Okay, so that's how you find an existing container. And if an existing container works for you, you can skip it to the end of this training and just go with the how do you use this in a job part. Um, but in general, most of the time, folks have their particular software that they want to install. It's very rarely a, simple standard setup. If it is, your life is going to be a lot easier. If it's not, your life is still going to be pretty easy if you use a container. So to make modifications or to make additions to the container, you have to build your own container. And what's really nice about this process is you can build on top of an existing container, so you don't have to start completely from scratch. We have guides on our website about using containers, and this includes also where things are listed. Um, what we're going to be doing today is following the process that's described in our containers Apptainer Singularity Guide. So pretty much what I'm going to be presenting or going through here in this process is just what we've already detailed in our guide here, maybe a little bit more digestible in a presentation format. But you can always check those things out on your own. So to start, if you want to participate in this hands-on, you'll want to log in via SSH. However you log into the OSPool, you can do that now. Now I'm going to be doing that as well. Once I get the right window up. So I'm going to be using my account that I have on AP40. So to log in, it's SSH, your username, and then at the web address or at the host name for the system that you have an account on. So it may not be AP40, it might be AP20 or 21. You'll have to authenticate however it is that you authenticate on the system. Let's see here. AP40, we use this click in the browser thing. And there we go. I am logged in. Now, because I'm an existing user, I've got a bunch of stuff, but I'm just going to make a new directory and go into there so I have an empty space to work with. If you're not sure how to log in or you don't quite remember, feel free to put a message in the chat. There's also the link to our login guides are in this slide as well, if you need a refresher on how to log in. Okay. Does anyone need another minute or two to get oriented, get set up? Okay. Not hearing otherwise, so I'll proceed.
Hold on, sorry,
Oh,
I just give me a second to log in. I'd like to try to log in, so.
yep, sounds good. We can wait a minute. Um, While folks are getting logged in, are there any questions about what I've discussed so far?
You can go ahead from now.
Great. Okay, so next what we're going to be doing, and you can do this in your home directory, or you can create another directory like I did. We're going to be creating a definition file. So in terms of the hands-on stuff, what you are going to need to do is copy the contents you see on the screen here, and I'll also paste that in the chat. You'll want to create a file that has these contents, and then I'll talk about what the pieces are. So I'm going to use BI to create my file. You could use Nano or Emacs if you know what those are. And in my case, I'm just going to copy and paste those in. Okay. So what is going on in this file? This is the definition file, or at least this particular definition file, instructs Apptainer on how to create the container that you want to use. This first line here, this bootstrap bit, tells it the protocol that it's using for fetching or building the container from. So we're using Docker here. And then the from line tells Apptainer the origin of the container we want to build. And so in this case, we are using, this is going to use Docker Hub in our Open Science Grid accounts. We are using this OSG VO Ubuntu 20.04 and just the latest version. So this is the starting point for the container process. This is already a container that's got a bunch, this is a container that has a bunch of things already installed, like Git and I don't even know what all else, probably Python and a few other things that just, the things that you're used to seeing on a system, on a Linux system. So we're going to use this as the base so that we don't have to, install Ubuntu from scratch or install, Git and Python and all these other things. They're already in the container. We just want to build on top of it. We want to add on top of it. And the instructions for how to do that are in this post section, this %sign post. Everything that comes or that is in this section are the commands that Apptainer is going to run on our behalf to build or to extend upon this base container. So you can just put in what you would normally do for installing something. So in this case, we're installing some things using the apt package, which is an Ubuntu package manager. And in that process, you usually have to do this updates to make sure it's got the latest links for everything. And then you do this install and the packages you want to install. This could be Git, this could be, your particular software if they've got an apt package. We're using -y here to tell it to confirm, yes, we want to do these things. Otherwise, it'll try to ask you, hey, are you sure you want to do this? And the way that Apptainer works is we can't answer that question. So we're providing that answer now. And then after the apt install section is this bit about Python 3-m pip install and this cowsay package. So we're just doing a normal pip install. We want to make sure that when this container is finished building, at the end, we have Python 3, and we have this cowsay package that we can use using Python. Of course, for yours, this could be a whole list of other, pip installable packages. And we don't have to stop here. We could continue on and do a make install of, git clone and a make install of some sort of, package we want to use, program that we want to use. Anything you want to do in the post section, you can put in this post section. All right, so I'm going to close out of that and switch back to my slides. And slides we had linked in the chat, and I also dropped the contents of the file in there as well, so you can copy and paste directly from there. Okay, so there's some other things you can do with the definition file. You can do an environment section. The environment section is for setting environment variables to be used at runtime. So when you're actually using the final container you created. The things that you set here in this percent environments are not set in the post section. So if there's something that you need set in the post section in order for a command to work, you need to add that particular command in the post section. But the idea here is, when you're starting up, you always want to add a particular location to your path. You can put that command in this environment section to make sure that happens. There's also a files section. So the percent files here is the file section. Oh, sorry. In this case, we're listing environment.yaml. So this is for the post section. If there's something, actually this is for the container in general, but usually how I use it is like the example here, which is that I have a conda environment.yaml file, and I want to use that to create my container. I can do that. I do this by putting the environment.yaml file in the same location as this definition file and add it to this percent files section. And then I can use that file inside of my post section or inside of my container when it's running, and have access to that file. It's going to get shipped around with the container itself. Okay. So where to install software? So in that post section is where you do your software installs. It's important that you avoid a couple of these locations here. You don't want to try and use $home in your install commands or reference/root or SRV. These are directories that are going to be usually overridden by the system. And if you install your software in those locations, you probably won't have access to them when your job is running. In general, a good location to install custom software is usually in the /opt folder or /opt, as I call it, or in /user/local. So that's if you're doing a manual install of some sort of package, a make configure install cycle. You'll want to use those locations for your install location. There's all sorts of more information about definition files, and you can find that in the Apptainer manual. So I'm going to skip ahead to let's do something with this stuff. So before we create the container, we're going to want to run these commands that I have on the screen, and I'll copy them into the chat as well. What these commands are doing is making sure we're avoiding using the root/temp directory. When we're building containers on the access points, it defaults to using /temp, which is relatively small. And if there are a bunch of people, such as in a training, all trying to build a container at the same time, that can fill up very quickly. So by running these commands, you are going to make sure that you have your own /temp directory in your home directory, and then you're going to be telling Apptainer to use that location when it needs to put any temporary files in. So I'm just going to drop those into my terminal as well. Hooray, no errors. And I can confirm that those were set by echoing the $ and then the variable name. And we'll see that this should be my home directory /temp, which it is. So that looks good to me. You don't technically have to do this, but we recommend it because there's a tendency for folks to fill up the temp directory and then you get some sort of error about not enough disk space. Okay, so what next? Let's just double check that we have this definition file. So I'm going to cat my definition file, which I called mycontainer.def, short for definition. And yep, that looks like what I had on the slide. So we should be good to go in that case. If not, feel free to make a change. The command that we're going to run next is pretty simple, and I'll be on the slide for a couple of minutes. So the command is apptainer build the name you want the container image to be called, and then the name of the definition file we're using to construct it. Okay, so that first one is what we want the container to be called. The second argument is the definition file that we already wrote. So I'll come in here and I should paste that in the chat as well. And I'm going to run this command. So we're going to see some stuff happening here. And hopefully, if everything's going correctly, we won't see any errors. So I'm just going to put this in the background and look at my slides so I can explain what's happening here. Okay, so you copied and pasted this command. Hopefully it started doing stuff and didn't just error out right away. What's happening? Well, this is an apptainer command. And what's happening to begin with is the first thing apptainer is going to do is get that base image that we specified in the from line. So it has to obtain it, has to download it from the internet, and then essentially run it. Next, if you did have a file section, it's going to be copying the files you provided there into the container. So into the running container, make sure they're accessible. Otherwise, everything that happens in the container is fully self-contained. So in this build process. And then it's just going to run the commands we provided in the post section. So in our case, that's going to be the apt update and apt install, and then the Python install commands. And once it's run all those installation commands, assuming they were successful, it's going to save that whole result of this installation in my container, the name that we provided, in this case, my container v1.zip. All right. Yes, so for the question in the chat, we are recording this. You can find it on our website, and I got a slide at the end that shows where. Okay, so hopefully everything goes correctly. There's no errors. What we're going to see is this message here at the bottom, info creating SIF file, info build completes, name of the container. So if everything went smoothly, and hopefully you also don't see any error messages, if we get to this step, that should mean we're good to go. Doesn't always mean it's the what you wanted exactly. You may need to make some changes still, but we'll talk about how to check that in a minute. All right, so switching back to my terminal, I'm just going to scroll through the output that it generated. So here is where I initially ran the command, this apptainer build command. We see starting build. This copying here it was downloading the existing container that I specified in the from line. It's then I call it inflating. I don't know if that's the right term, but it's running that container that it downloaded. Then it's running this post scriptlet. So %post is short for this post scriptlet. And you'll see the commands that we told it to run prefixed with this plus sign. So I told it to do an apt get update -y. And I see the output that I would normally see from running that command, which is that it's getting some archival links and various things like that. And then done. Cool. Our next command was this apt get install, and then these particular packages. So again, prefaced with that plus sign. And this is the usual output for doing an apt install. So we see that it's looking at the links, figuring out the dependencies, is going to install Python 3 NumPy, but it turns out that the version that came with the original container is already at the newest version. So it skipped over that step. Then it was doing an upgrade of pip to make sure we had a good pip installation here. And this is just the usual stuff for apt. Another plus sign here, this was our last command we wanted it to execute, this pip install of cowsay. And here you can see that it's doing a normal pip installation. Everything ran correctly. I didn't see any error messages, and it's finishing up with this creating the SIF file. It created it, and if I do an ls now in this directory, in addition to my DEF file, I now have this new SIF file. Don't try to open this. Don't try to open it in your browser. It's just it's a compressed binary or something like that. So it doesn't make any sense to open up the file itself. But this is what Aptainer can use to create the container, to actually run the container with that software we asked it to install. So this file is everything we need in order to replicate this software environment that has this cowsay and Python 3 and whatever else we had in that base container. Okay. I will just caveat, just because you see this message at the end creating CIF file doesn't mean that the installation commands work successfully. I have noticed with some programs, they don't trigger the right exit message or something like that. And there will be an error, this thing did not install error, and it'll keep going down into this section anyway. So if you're having weird issues in the testing, it could be that you missed an error message in the outputs when you built the container. Addressing that will hopefully address the problem, but that's something that we can help you with and over email or in our office hours. Okay. Well, I did something. I created this SIF file. How do I know it's what I wanted? Well, you can test the container on the access point. So we can do this with the aptainer shell command, and I'll show what that is in a second. Your home directory is going to be automatically mounted. Mounting is a bit of a tricky thing, but basically it's going to look like you're in your home directory when you're doing this on the access point. But just keep in mind, we don't want to run any long or intensive calculations or commands or scripts on the access point. The single exception to this is building containers. Anything else should be something short, simple, take more, less than a minute to run. Otherwise, you should be doing it inside of an OSPool job. For a simple test of our container today, though, we can do this on the access point. That's no issue. If you wanted to test your full, I don't know, data analysis pipeline or whatever it is that you're doing on the OSPool, you're going to want to run a test job, not just test the command on the access point. All right, so I'm going to demo this for you as well here. We have this aptainer shell command. This is a way of launching a container. So this is to run a container. And when we run this command, we are going to have access to the software we installed in that container. So that's what I'm going to do here. And again, this is in the slides, and I just put it in the chat as well. So aptainer shell in the same way that bash is a shell or sh is a shell, and then the container image file, this SIF file. And if I run that, I'm going to see my prompt change because we're using a more recent version of aptainer. The prompt says aptainer. If you're using an old version or if you're using Singularity, you might see Singularity instead. So in this case, I am now inside of the container. And it's kind of hard to tell right away because if I do an ls, here's my files that I was expecting. But if I do let's see here. I'm going to grab this. So while I'm in this container here, if I look in the OS release information in the etc folder, and I look for the value of pretty name, I see that pretty name is Ubuntu 20.04. Now, I realize I didn't demonstrate this before I did Apptainer Shell, but our access points are running CentOS Stream 9, I believe. So for me running a command now, after I did this Apptainer Shell in the container file, it seems as if I'm on a completely different operating system. And not only that, the Python 3 that I'm going to have in here I got 3.8.10. And if I go into the Python console and import calsay, I didn't get an error. So if I try to do this on the access point, and actually, I think once I demonstrate this, I will switch to the access point and show you what it looks like. But if the package doesn't exist and you try to import it in Python, you're going to get an error message that says, module does not exist. So if you wanted to do this yourself, we're using the Python console, import calsay, and the calsay module has a set of commands where you can type messages. In this case, we'll do hello OSPool, but you can change it to whatever you want. And when we run this, we'll get a pretty cow, an ASCII cow. So you can change this message to whatever you want, and you'll get the same thing, and there's whatever else. It's just a simple little program that's nice for demonstrating things. So when I'm done playing around in the Python, I do exit parentheses to exit the Python console. I see my prompt is still apptainer. If I wanted to no longer be in the container, if I wanted to return to my normal login, I exit this special shell that we launched. And then you should see your regular login prompts come in. So just exit again. All right, I mentioned I wanted to demonstrate, so let's take a look here. So earlier I ran this commands. We saw the output was Ubuntu 20.04. If I do that again, there we see what the actual operating system on this machine is, CentOS Stream 9. Did someone have a question? I saw a hand raised.
Oh, sorry, I was going to type it in because did you say that if you put that environment.yaml file in the same directory as container.def, that
Yep.
you can use it to build the content environment? Thank you.
Yep. All right, and then if we take a look at the Python version, on the login server, our Python version is 3.9. In the container, it was 3.8. And if I try to do the calsay thing here, I don't remember if I tried to use calsay before. I get a no module found, right? So this is on the login server. So what that apptainer shell command did and what this container.sif file provides is essentially a completely different operating environment, right? To me, running the commands, it looks like I'm running on a completely different computer than what I actually have on the system. And so this is really the power and benefit of containers, is this ability to essentially create or use a completely different operating system, completely different set of libraries and programs and packages than the machine where my calculation is actually running. And this is very powerful for the OSPool in particular, where we have such a diverse set of machines, each with their own set of programs and things like that. Okay, let me switch back. All right, so question from Joseph.
Since the container is completely contained, can we assume that all the security is now the responsibility of the host system? So if I wanted to, God forbid, run something under CentOS 5, I wouldn't have to worry that I haven't done security updates for 10 years.
That's a good question. And I believe the answer is yes, you still have to worry about it. It gets complicated, but um, if you don't need internet access, then you don't have to worry about it. So if you're not downloading something from the internet, then you don't have to worry about that level of security. But yeah, it is potentially a security risk, because if that CentOS 5 that you have has significant vulnerabilities, it's subject to whatever sort of attack. Um, then if you download software from an unverified source and it happens to have that attack in there, now that execution is compromised. That the way that we execute containers, that will not infect the machine itself. But there was an example where someone got a container from an unverified source and it had Bitcoin mining injected in there. And so this person who was running jobs on the OSPool was completely unaware that they were mining Bitcoin for a malicious person. So it is important that you verify the source of your containers and you know what they are. They're from trusted sources. And unless you're downloading things from the internet, then you shouldn't have to worry about things. But even if something does happen, then because of how containers are executed, or at least the way that we execute containers, that vulnerability will not spread to the host machine or the rest of the machine. Casper.
Thank you. My question is, I mean, you can build this on your own if you already have an apptainer for what you want to do, and if you can transfer it to your access point. Is that correct?
Yep.
Yeah, you don't.
Yeah, so
No.
yeah, you don't have to build on the access point. Software installation can be an intensive process, so it's nice to be able to do it on a machine where you're not also writing emails and writing papers and things like that. But yeah, as long as you've got apptainer, you can on your machine, you can do apptainer build on your machine, and then you just need to transfer the SIF file to the system. The one thing I will caveat about that is the apptainer build command does automatically detect the CPU architecture of a machine you're building on. So if you've got a newer Mac using the M1, etc. chips, which is the ARM architecture, you build an apptainer container on there, or even a Docker container on there, it'll automatically detect that ARM architecture, which is not compatible with the x86 architecture we use on our systems. So in that case, there is an option that you can set to tell it that, hey, you're building the container to operate on this CPU architecture, and then you don't have to worry about that detection. Just something to keep in mind, though.
Yeah. Thank you.
Yep. Okay. I'm also going to demonstrate this sort of mounting thing that I mentioned. Oh, PJ,
Yeah, so
I'm not sure what
I do have a question. I'm sorry.
Yeah.
Do you recommend that people use OSPool for say things like CI/CD testing? So I build containers regularly. It's like both flavors, Dockers and Singularity ones. And the reason I need one of those is that my actual deployment has to be done on a machine which contains a GPU, and we typically use the OSPool for that.
Yeah.
So is it possible to set up hooks to directly access it? Or like when I push to GitHub or GitLab and I want to be able to trigger my CI/CD run directly on OSPool rather than.
Yeah, I don't know off the top of my head, mostly because I don't have experience with GitHub Actions and hooks, things like that. I would suggest you can stop by our office hours and one of us can just help you explore that sort of thing. I don't think that's strictly related to containers. So that's a whole nother can of worms I don't want to get into today.
Okay. All right, thanks.
Okay, so one thing with this apptainer shell commands, you may have noticed it, and I may have pointed it out, is that it's automatically mounting in the home directory when you execute this apptainer shell. So this could be useful, but one thing to really note here is that your home directory on the access point only exists on the access point. So when you're running jobs, you don't have access to your home directory. But I'm still going to demonstrate this because it's a useful insight into how the container works in general. So I'm just going to do the apptainer shell command again. So this is, I had this in the chat earlier before going into the shell. And I'm going to do a simple command to just write something to my file. So let's just check what directory I'm in. It looks like I'm in the same directory as I was when I ran this command. I'm going to save a file or save a message to a file. Okay. If I do ls, I see that. If I take a look at it, okay, there's my message. All right. So that's pretty simple here. Next, I'm going to exit back into the server again. So this is just to take a look at, I'm just back in the normal view or normal login server here. And if I do ls, I see that file again. And if I cat that file again, I'm going to see hello OSPool. Even though right now I'm on the login server and the container is no longer running. So this may or may not seem obvious to you, but in this case, when we executed the container, the file system that we are on was automatically available. This is going to be mostly true as well when you execute a job on the OSPool, except instead of being your home directory, it's going to be the job's working directory. Otherwise, there are ways of launching a container where it is totally and completely self-contained, meaning that it doesn't write anything to the file system, and when you exit the container, it all disappears, whatever it was. And that could be useful for doing like service type things, but usually on the OSPool, folks want to save their output files, bring them back with them. So we've reflected that behavior in how we manage or how we launch containers on the OSPool. Okay. All right, so we tested the container. We saw that we were able to do the cowsay commands in this particular case. So for me, and the purposes of this, my container is good to go. So now I want to use my container in an OSPool job. In your case, when you're building the container, you may run into issues that may only become apparent when you test it, may only become apparent when you actually try to use it. At any point, you can revisit an earlier step, make changes, and do it all again. So here, our container is good to go. We're going to go ahead and set this up for usage. Container files are usually large files, and just like any large file on the OSPool, we want to put that into if you're using one of our general access points, we want to put that into your data folder, or in more generally, something that's accessible via the OSDF. So for our example here, we're going to be putting it under OSPool, and for me, I'm on AP40, so I'm going to put it under the AP40 directory in /data / my username. And then in my submit file, I'm going to have this line plus singularity image, and it's going to use the OSDF protocol to reference that file in that location on the access point. All right, so let's get this set up here. All right, and I don't remember how to check what my data folder is. Nope, that's not it. Okay, if I remember right, when I log in, it's There it is. In the quoted message, it shows what your data folder is. And of course, it is the same as what I was just talking about on the slide. So the slash OSPool, the AP that you're logged into, slash data, slash your username. I probably already have, oh, I don't have any stuff. Oh, that's right. I used to have stuff in there, but okay, so what I'm gonna do is copy my container v1.sif. I'm just going to copy that into my directory. So you can do this as well, but you should use whatever works for you. So if you're on a different AP, you need to change that AP number. You are certainly a different username than me, so you should change it to your username, but you should be able to do that command or a version of that command, and hopefully it works. And I'll type this in. And I put in caps the things you need to change. Okay, so now if I do that ls command again, I see I have that file there, great. I'm going to create a submit file. So let's see here. I'm also going to create an executable file. Okay, so I'm going to create a submit file. Here's the contents. I'll also post them maybe into the chat. So make sure that you change the value of AP20 and the value of user here to be your particular path. Simplest thing is you can just replace the things, copy and paste those that you have in the chat. One thing I'm realizing is that the quotation marks in what I just pasted in there are not correct because they're the nicely formatted one. So you'll want to change that line to this. And actually, I'll just paste in the whole thing again. Quotes in Zoom chat can be a pain. If you get some weird error, that's probably the issue. So I'm going to create this file, job.submit. And in here, I'm going to paste what I just put in the chat. Again, remember to change your AP to be your particular AP. So in my case, it's AP40. In your case, it might be 20 or 21. I'm going to change it to my username. And if you're not sure if you did the right thing, or if you typed it correctly, just copy that path that you had and do an ls. You should see the file. If you get no such file or directory, then you've changed that path incorrectly, and you just need to figure out what it should be. Okay, so that's the submit file. But otherwise, it's a pretty simple submit file. And in fact, if you've submitted jobs before on the OSPool, it looks barely any different than the jobs you've submitted before, right? We got the usual resource requests. I'm defining an executable, this lolcow.py. We'll need to create that before we submit the job. But then output error log P1 job. The only thing that's new is this plus singularity image here as well. And so this is going to tell HGCondor that we're using this as our container environments, and HGCondor will handle it from there, which is really convenient. And that means in our executable, we don't have to have any apptainer commands in this executable file, no installation commands in this executable file, just whatever command we want to run that makes use of this container environment that we created. Okay, so that's the submit file. Oh yeah, so someone put in the chat, you can specify GPU needs in the job submit file. And Mott's just provided a link in our documentation. Yeah, everything about the submit file is the same as you normally would do it. You just add this one line plus singularity image. That's regardless of whether it's a GPU job, a checkpointing job, what have you. We're going to create an executable file. We're going to call this lolcow.py to match what we have here in the executable line. So I'm going to quit VI, which I know how to do. And then we're going to create this lolcow.py file. So it's going to have this as contents. So I'm going to open up that file and create that. You can change this message around if you want. I'm going to change this to hello OSPool. Okay. And one thing that you'll notice here is that in the shebang, the first line of the script, we're telling it to use Python 3. And what's really nice about containers now is we don't need to have a wrapper script that tells it what program to execute. As long as we have user bin Python 3 in the container, then this will automatically tell it to use that program to run these commands, which is pretty nice. Okay, so we got this lolcow.py. We got the submit file. And now all we need to do is submit the job as we normally would. So Condor submit job.submit. And that should be good to go. I'm going to use Condor watch queue to just track the live progress here while I'll put these commands in the chat as well. And then Dan, you had a question.
Yeah, I was just trying to clarify about where we were creating these files, but when you did the job submit, I understood where we were at, so it was fine.
Yeah. Yeah, so the .sif file we want to put into that OSDF enable directory just because the container file is usually large. And so we want to take advantage of the OSDF system for transferring it. But otherwise, yeah, it's everything else is normal. So submit file, executable file, still on the home directory. That started faster than I expected. I got some output files. Let's take a look. To exit Condor watch queue, do Control key C to cancel the command. I'm just going to take a look at this output. And there we go. We got hello OSPool back. I presume that my error file is empty, which is great. So this job ran successfully, which is even better because I did not have time to retest these things with training. So what happened here? We did Condor submit and the submit file. We provided this plus singularity image option. And this is a way on the OSPool, so this is specific to the OSPool, for telling htcondor where and how to run the container. So when we provide this plus singularity image, what's going to happen behind the scenes, htcondor is going to transfer that file. So in this case, we use the OSDF protocol to transfer it. The temporary directory that was created just for that job is mounted in to the container. And the executable script we provided is run directly using that container. And so for that executable script as far as it can tell, the software that it has is whatever was in the container. It is inside of that container environments that we created here, that you created. And it doesn't know or have access to the software that's on the host operating system. And that's really nice for having a reproducible environment for executing your calculation. You'll also notice that in our executable, there were no apptainer commands. I wasn't doing anything with apptainer in the executable. I don't need to, and unless you have apptainer installed inside of the container itself, it's a bit nested and meta there, bit inception. You can't use apptainer in your job. This is something that the system is doing automatically on your behalf, using its copy of apptainer that it has. So you don't run any apptainer commands in your container. You just run whatever it is, your program, your script that you want, that you have installed in the container. So best practices here about using containers on the system. In general, you don't want to use the latest tag when you're specifying an image. So if you're grabbing an image from Docker Hub, an existing image, you don't want to use latest, or at least you want to avoid that if you can. You want to grab a specific version number, a specific name for the image. Our systems do some heavy caching, and what that means is when you run a job, if we've already grabbed that container, we've got a copy of it, and we're going to use that copy regardless of whether or not you've made changes. And so that's especially in combination with the OSDF, that can be a real headache. You make a change and it doesn't have the right tag set up. So you'll notice also that when I created the container image file, I added my own version tag to that container image. And that's because I wanted to transfer this via the OSDF, and the OSDF uses caching. If I realized that there was a mistake when I built my container and I need to change the contents of the definition file and redo that apptainer build step, I want to change the name of the container I create so that it's something different from what's already in the OSD. We went through this earlier, but you'll want to test your image with apptainer shell. I personally found that if I can get the help message for the command I want to use to print, it's usually in a pretty good spot. So if you can get the help version message for whatever command or module or program you're trying to use, I've found that correlates pretty nicely with it's functional. And then this last point, I think I made this earlier, but on our systems, the containers are going to execute as a user and not as root. It's very common for containers or container approaches when you're running it on your own computer to assume or expect that the container is being launched and executed as the root user, especially if you're working with Docker. That's fine when you're running on your own computer, but of course, on a shared resource with access to hundreds to thousands of machines, we can't give you root access. So we do not launch these containers as root. And that means some of these expectations that certain containers have are going to be broken. They're not going to be able to function the way you expected, because they're fine when they're executing as roots. They're not fine when they execute as user. All right, so that is most of what I wanted to cover. This is just an introduction and orientation to containers. We are here to help you. So when it comes to building your particular container, installing your particular software, feel free to send us an email, stop by our office hours, and one of our team is going to be happy to help you out. Someone was asking about OSPool trainings. The current training schedule is on our website on the main training page. Past trainings are available in a subsection. I think it's past materials or something like that. And the video for this recording will be dropped into one of those pages at some point. I don't remember what the sequence is. Supposedly there's a feedback link. I forgot to fetch that, so we'll jump back to that in a minute. And then acknowledgements. This is part of work supported by the National Science Foundation. All right. Questions here. Oh, slide link. Yep, we can drop that in. And I think I'll also stop the recording so folks can feel free to ask their questions.